All right, today's lesson is on histograms, helping you learn how to read it and how to find them in your camera. So a histogram, like represented on the far left-hand side of the screen there, this is a screen capture using Adobe Lightroom software. However, your histogram is visible after you capture every image, or if you have a mirrorless camera, you can even see a live histogram before you capture the image. But the histogram itself, it's a graphical representation of all the exposure values that you captured in your image. So notice this particular one has multicolors. Your camera may just show black and white histograms, and that's fine. We're looking for the overall shape, the shift, and if it goes too far off one edge or the other, then we call that clipped. So let's find out more here. And as we look at these histograms, we often think about exposure and is it good exposure? Whoops. There we go, good exposure or not. And so we're really identifying the far left-hand side are your black tones and the far right-hand side are your white tones. So that is true black and white in your image. This particular image that this histogram represents doesn't have any black or white. You will see the image in just a little bit. The height of the mountain range, as I call it, represents how many pixels in those color areas. So we do have, or light areas, we do have just off white, we have quite a few pixels there, but in the dark areas, we have quite a bit as well. And then there's some in between. So I mentioned earlier the word clipping or clipped. And so this is an example of histogram that's shifted to the right, and it's shifted because it is clipped. It is too bright, it is overexposed. And you can see the pixels, the information of the histogram that is falling off to the right-hand side. It's clipped off the box. So everything's about seeing that tonal range, that mountain range within that little box area. If it's shifted all the way to the left, you can see that it's clipped and it's underexposed. We tend to be more concerned on overexposed images than underexposed images because if it's overexposed, you've really lost detail in some of the brighter areas. So, but it's a good idea to recognize both and to avoid clipping in general. And then this would be considered the proper exposure. So this histogram notices it fills the box from left to right quite well. So you've got a full tonal range and it represents the image well. The image has a full tonal range. So we have the bright white reflections on the tomatoes and we have the dark shadows underneath. So it's your histogram does represent your subject. If I had taken a picture of a polar bear in the snow, it would probably be most all of the histogram would be on the far right, but there would be a couple little pixels down on the bottom left with the eyes of the polar bear and the nose of the polar bear. So it all represents your subject. So let's go back to that original histogram. We've got some light areas and we've got some almost black areas, very dark areas. Let's look at the picture. Superstition Mountains. So those dark areas are the shadows in those canyons. And then the bright areas are on the far left where the horizon meets the ground. And that's why it doesn't go to complete white. It still has some blue in it. Here's another histogram. So hopefully you look at this and you start thinking, oh, what does the tonal value of that image look like? So when I read this histogram, I see a lot of blacks and I see a lot of dark areas as well. But the tonal values do fill the box. So I do have a full tonal range. And here's the image. So the silhouettes forced all those dark pixels, but I still have, because of the sunburst, I still have some bright pixels in there too. And another example. A lot of white pixels on the far right. Doesn't go completely to white, but close. But it still has a full tonal range because I have filled my box from left to right. And there's the image. So that background is pretty white, but not completely white. If it was completely white, it would blend in with the background of this presentation. So it is about a third of a stop underexposed, the white area, but we still have some nice detail in the black kitten and the toys. Another example, a whole lot of dark pixels, but still a full tonal range. And there's the image. The water reflections created a black scene, so that's where all the dark pixels come from, but the bright areas on the leaf help fill out the complete tonal values of the image. And one last example. A lot of what we call mid-tones, because more of the middle of the histogram has all the pixels, although it does still have a full tonal range. And there is your image. So the brightest areas would be where the light's reflecting on the rim of the hat. The darkest areas would be some of the shadowed areas. But the rest of it, this is a full sun photo, midday photo. So the rest of it really is kind of generates midtones, middle of the line colors. So that's how to read a histogram and to recognize if it shifts or not. So let's talk about turning it on your camera. So first off, if you have a non-mirrorless camera, after you view an image, play it back, then you should be able to use your thumb pad or one of your toggle switches to sort through information on the photo, and you should see a histogram. If you're on a Canon camera, sometimes that means you have to hit the display button. Nikon cameras, you often have to turn that feature on in a sub menu. So if you need help, do a Google search or take a look at your camera manual to find that feature. If you have a mirrorless camera, you even can see it in playback, but you can also see it live. So as you're taking the picture, you're going to see the histogram there through your viewfinder or on the LCD panel. It can be a pretty handy feature, especially as you're first learning how to use a histogram. So I highly recommend turning that on and testing it out. So hope the review was helpful.